Okay, now we're going to start looking at code. This is going to be for the text view, which displays text on the screen. If I write this block of code, then the phone looks like this. Now I know this may look a little funny to you, because it's not like the normal words and sentences that we're used to every day. We're going to go over this in a little bit, but first I want you to make some observations about this code. Write at least 3 things you notice about the code. Include things that make sense, as well as things that are strange or confusing to you. Thanks for your response. There's no right or wrong answer here, so let's talk about a couple of observations that you may have made. First, you may have seen that there's these weird angle brackets at the start and end of the code. There's also this weird /, but it only happens at the end but not the beginning. And then it says text view, which we recognize because we introduced it earlier. And it's showing up in camel case format with the T and the V capitalized. And then you might see something about Android : text, and the punctuation might be a little weird here, to have a colon and then an equal sign. Then we see something that says happy birthday, and this is showing up exactly like we see on the phone, so somehow they may be related. So this can be an observation as well. Then we see something about a background being some color that's darker gray. And the text view does have a gray background, so this could also be linked. You made some good observations in the last quiz about the XML that we showed you. Now we're going to talk more formally about the XML syntax. Syntax means the rules that define what valid XML is. If you write invalid XML, then it won't even show up on your phone. This is the code for the XML element called text view. We always start with an opening angle bracket followed by the view name. This could be image view, button, or any other type of view. Then we have a list of attributes here, 1 per line. And then we have a / and then a closing angle bracket. There's a lot of symbols and characters here. To help you remember it, you can think of an opening angle bracket, ding, and then the view name, whoosh, and then the attributes, pew, 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 and then the /, and then the closing angle bracket, boom. So altogether it's ding, whoosh, pew, 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 boom. If you miss any of these symbols, then you're going to get invalid XML. Here's the reasoning behind what seem to be arbitrary symbols. For every XML element, when you start or open up a tag, you always need to close it. It's kind of like putting a period at the end of a sentence, but for XML, instead of a sentence, you need to make sure you close each tag. Because we start the tag here and then close it right away, this is called a self-closing tag. Instead of a self-closing tag, you could have a separate opening tag and a separate closing tag. Here's an example where it would be useful. This is for the linear layout view, which is what you're going to learn later in this lesson. But just know that this is the opening tag and this is the closing tag. The closing tag is the same, except it has an open angle bracket, a /, the name of the view, and then a closing angle bracket. So the difference between the opening and the closing tag is this /. And you'll also notice that in between we have 2 text view XML elements. These are also called children XML elements within the parent linear layout. You can imagine that if you had a self-closing tag up here for linear layout, then you would have no idea how many children it contains. But now that the closing tag is down here, you know exactly that you have 2 children. In our case, for the text view, there are no children XML elements, so we can just do a self-closing tag right away because that saves us from having to write open angle bracket / text view closing angle bracket. You'll notice that we have a bunch of additional text inside this tag. These are called attributes. Attributes are characteristics that determine the behavior or the appearance of the view on the Android phone. For example, you can think of it with this analogy. A person has attributes like black hair and brown eyes. A text view has attributes like width, height, background, text, among many others. Looking more closely at the format of each line, we have the attribute name on the left-hand side, underlined in yellow here, and on the right-hand side we have the actual value. It's important to note that the attribute values should be put in quotation marks as part of the syntax for XML. Then we have an equal sign in the middle to say that the attribute name on the left is set to the value on the right. So the text for the text view is happy birthday, and the height is 75 density independent pixels. All of these attributes have default values, and there's attributes that we didn't even list here. That's because the text view has default values for all of its attributes. If you're okay with the default values, then you don't need to set them here. You should only write lines of code here that you want to be different than the default values. For example, the default background color for a text view is a transparent color, but we wanted to set it to be a darker gray color, so that's why we have this line of code here. One more important note. Humans are pretty smart. If I write phrases like this, you probably know what I mean, even if I'm not using proper English punctuation or grammar, or even real words. However, computers are not as smart, so you need to use the precise symbols and names that they recognize. Otherwise, they won't know what you mean, and there will be errors in your code. Here's an example. For the name of the view, we can't spell it txt view, or text view with a lowercase v, or text view with a space in it. These are all incorrect, and the computer won't know that we actually mean text view. If we want text view, we need to spell it exactly the same way with a capital T and a capital V for camel case. Attribute names need to be spelled out this exact way with a colon after the Android. We need to have an equal sign, and then we need to put quotes around the values. One more time so you don't forget, it's ding, whoosh, pew, 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 boom. Now that we've gone over the syntax rules of XML, can you answer these questions for this XML element? First, what is the name of this XML element? Then, can you list all the attribute names separated by commas, not the attribute values? Then, on what line number is the tag closed? To help you, I've written down the line numbers on the left-hand side. The answer to the first question is that the XML element name is here, text view. It follows the open angle bracket. Then all the attributes are below the XML element name, and I've underlined the attribute names here. They're on the left-hand side of the equal sign. They include Android text color, and so on. If you put the attribute values like happy birthday or the color white or black, that's incorrect because those are the attribute values, and I was asking for the names. The last question is, on what line number is the tag closed? and we see the forward slash and the closing angle bracket on the last line, which is line 6. This means that it's a self-closing tag because we open the text view tag here and then we close it right away.
Okay, so we've seen text view code for the first time.
But it's kind of hanging out in limbo.
Right. We do need a space where we can sort of house it.
Yeah, and that space is an IDE.
Wait, there's that acronym again.
Yeah.
What did it stand for, Catherine?
Integrated Development Environment.
Right. And we're going to be using Android Studio in this class. This is what it looks like. Still a little intimidating.
Yeah, I think we might need something that will help our learner ramp up a little bit easier.
Right. So we've been working on developing something that is Android Studio on training wheels, and in the tradition of really convoluted acronyms in computer science, we are calling it XMLV.
Which stands for XML Visualizer.
So you write a little bit of XML, you get to see the output. You write some more, you get to see more output.
Yeah, so let's go use it.
Okay.
Since this XML Visualizer was created specifically for this course, it won't provide all the functionality that Android Studio supports. But eventually, in the problem set of this lesson, we'll get you into Android Studio so you won't need this website anymore. A link is in the instructor notes if you want to follow along. For this code, the text says happy birthday, so when I look at the device, it says happy birthday. Now let's try to change the text to happy birthday, Kunal. And then when I zoom in on the device preview, you see that it says happy birthday, Kunal. Now what happens if I try to change the width and the height? I'll pick some arbitrary values like 300 dp for the width and 500 dp for the height. And now in the preview pane, you see that the text view is a lot bigger. The text, though, however, is still the same size in the top left corner. Notice that for the width and height values of 300 and 500, it is followed by dp in each case. This is a unit of measure, like centimeters or millimeters, that we use to describe the size of views on Android, as well as the distance in between views. The unit dp stands for density independent pixels. Let me explain why we need that. Say these beautifully drawn rectangles represent different devices. They're the same physical size, but they differ in terms of resolution. This is a medium resolution device with a medium number of pixels on the screen, high resolution, and an extra high resolution device. When I say pixel, I mean a phone screen is made up of many tiny squares which are pixels, and they light up based on what you're looking at. So if I define the size of a view, for example a button, to be 2 pixels tall by 2 pixels wide, this is what it would look like on a medium resolution device. On a high resolution device, it would also be 2 pixels by 2 pixels, but it's a little bit smaller because there's a lot more pixels trying to be packed into this device. And then on an extra high resolution device, where there's tons more pixels packed into this space, this button is actually pretty tiny. I can barely tap on it with my finger. I have to use the edge of my finger or my fingernail to reach it. Just because I have an extra high resolution device doesn't mean I have a smaller finger. I still want to be able to tap the buttons on the screen. And that is why we have density independent pixels. I can define my button to be 2 dips tall by 2 dips wide. And this is what it would look like across the different devices. It's the same physical size, but under the hood, Android is mapping it to a different number of pixels. You don't have to worry about any of that logic. All you need to remember is that you need to define your sizes in terms of dip values. When designing your apps, we recommend that all touch targets, like buttons, should be at least 48 dips tall and wide. Notice that it says 48 dips and not 48 pixels. Otherwise, it would be really tiny on this extra high resolution device. This will make your app easy to use for everyone. So with all of this knowledge, I want you to try and change the text view code now. You're going to be writing your very first lines of XML. How exciting! So first try to change the text in the text view, and then try to change the size of the text view. Then I want you to try to create an error, sad face, and then I want you to undo it, happy face.